ICSE warriors. My name is Prachi, and in today's session, we are working on the fourth test paper of the series. If you are new to this channel, we are talking about a test series that is going on for chemistry 10th grade ICSE, and we have a chapter-wise revision going on. Every day we take up one test paper from each chapter and we discuss that. Today is the fourth chapter, that is analytical chemistry. If that is something you might be interested in, go ahead, subscribe the channel now and also join the Telegram channel for us. Now, without wasting any time, my dear students, let's move ahead with the solutions of analytical chemistry. So students, I hope my screen is visible. This is the test paper that you would have received on the Telegram channel yesterday, and you get one whole day to work on the test paper before a video comes out in which we discuss your doubts. Other than discussing the doubts in the video, if you have any other concerns, you can directly contact me on the Telegram channel and I will be happy to help you out. Now, let's begin with the understanding that when we're talking about any test paper in the series, I have an assumption that you have at least read and learned the chapter and you have basic understanding of the concepts before you attempt the test paper. Because in that way, you can judge your skills and understand the areas that you lack in and accordingly work forward. Okay. So in this chapter also, in this test paper, I'm assuming you have basic understanding of the chapter. This chapter is completely about learning equations and what are the different effects of different solutions, what kind of PPTs we get and what kind of gases come up. Now, let's move ahead without wasting any time. So the first question is, match the description below with the appropriate substance out of the following. You have sulfur, silver chloride, hydrogen chloride, copper sulfate and graphite. And the definition given to you is a compound which is insoluble in cold water but soluble in excess of ammonia solution. So the answer for that should be silver chloride. Then moving ahead, select the correct answer from the choices A, B, C and D which are given. The first is the metal oxide which can react with acid as well as alkali is. Okay, such an oxide is known as amphoteric oxide. That means when amphoteric oxides react with acid, then also you get salt and water, and when they react with bases, then again you get salt and water. So let's look at the options. I have silver oxide, no. Copper oxide, no. Then you have aluminium oxide, yes. So aluminium oxide, yes, Al2O3 is an amphoteric oxide which when reacts with an acid gives salt plus water, when reacts with an alkali gives salt and water. So the answer is aluminium oxide. If for any part you need me to give you any more examples or discuss it further, please make sure that you drop a comment in the comment section and I will get back to you. Now moving on, carbon dioxide and sulfur dioxide gas can be distinguished by, so moist blue litmus paper, no. Lime water, no. Then acidified potassium dichromate paper, yes. So carbon dioxide will have no effect on it, whereas sulfur dioxide will turn it green. Okay, so this is why we can use acidified potassium dichromate. So CO2 will have no effect and sulfur dioxide will turn green from orange. Now next is third is identify the substances PQR in each case based on the information given below. The deliquescent salt P, deliquescent means something that has a tendency to turn liquid or stay in liquid state. So deliquescent salt P turns yellow on dissolving in water and gives a reddish brown PPT with sodium hydroxide solution. So what is turns yellow on dissolving in water and gives reddish brown PPT? So that should be your FeOH whole thrice, which is reddish brown, and yeah. Now, so the solution or the salt P should be ferric chloride for you. So ferric chloride. Moving to the second one, The white crystalline solid Q is soluble in water. It liberates pungent smelling gas which when heated with sodium hydroxide solution. So when sodium hydroxide solution is heated, you get ammonia gas. So your pungent smelling gas is ammonia. That would mean your white crystalline solid is ammonium chloride. Ammonium chloride. Moving on to third one, the pale green solid R. You have pale green solid R that turns reddish brown on heating. Okay, pale green turning to reddish brown. Okay, we have a basic idea of that. Its aqueous solution gives white PPT with barium chloride solution. The PPT is insoluble in mineral acids. The answer should be ferrous sulfate. Ferrous sulfate. Now the fourth, give one chemical test to distinguish between the following pairs of compounds. So in these you should have good understanding of the ions, how they are reacting, what kind of PPTs they are forming with what solutions, so that you are easily able to distinguish between them. For example, if we start with the first one, zinc sulfate and zinc chloride solution, so you can say we can use barium chloride. So I'll just write that barium chloride. Why are we saying barium chloride? Because zinc sulfate will, a PPT appears for zinc sulfate which is insoluble. So for now I'm just telling you the answers, and then as we move on I'll just try and find some space and write the answer for you. So for the first one we'll be using barium chloride. Why is that? Because zinc sulfate will show PPT which is insoluble, and whereas for your zinc chloride there won't be any visual reaction to be visible. The second is iron 2 chloride solution and iron 3 chloride solution. So for that we will be using ammonium hydroxide solution. Why is that? Because your iron 2 chloride will be giving you dirty green. Just let me write this, ammonium hydroxide solution. So when we are using ammonium hydroxide solution and it is reacting with iron 2 chloride, a dirty green PPT will appear which will change to reddish brown. Okay, and when we are reacting with iron 3 chloride, in that case you will have a reddish brown PPT which is insoluble in access. Then we have calcium nitrate solution and calcium chloride solution. So we'll be using silver nitrate solution for that. Let me write it here. Silver nitrate solution, because for calcium nitrate no visible effect is seen, whereas for calcium chloride solution a white PPT appears which is soluble in excess. Okay, a white PPT appears which is soluble in excess. I will still make sure that I write the answers right here once I'm uploading this. Then moving on to the next one, question number 5. Select the correct answer from the choices A, B, C and D which are given below. The salt which in solution gives a pale green PPT with sodium hydroxide solution and white PPT with barium chloride solution. The answer is very simple, that is iron 2 sulfate. Iron 2 sulfate. Moving on to question 6. What do you observe when excess of ammonia is passed through an aqueous solution of lead nitrate? Think about it. Pause the video right here if you have not solved the questions before and think about it. What will you observe when excess of ammonia is passed through an aqueous solution of lead nitrate? So, let me write it here. A white PPT appears which is insoluble in excess. Then moving on to question number 7, match the following. So the first one is, okay, first you if you notice column 1 is all of the gases. I can see carbon dioxide, sulfur dioxide, hydrogen sulfide, hydrogen chloride, nitrogen dioxide, and over here we have some characteristics, either smell or the color that is given to you, so you have to match them. So if we think about this, carbon dioxide is a colorless and odorless gas, so this would become B. Sulfur dioxide, so sulfur dioxide has a burning sulfur smell, so A. Hydrogen sulfide, if you think about it, it is a rotten egg smell. So you will have D right here. Then hydrogen chloride, HCl. So that will have what? Think about it, students. If you would have done the chapter HCl, what can it be? What are we left with? We are done with colorless and odorless. We are done with burning sulfur smell, and we are done with rotten egg smell. So we are left with colorless gas fumes in moisture and reddish brown colored. So nitrogen dioxide is reddish brown colored. So this becomes a C, and this becomes E. That is, if you remember that we had preparation reaction of HCl, in which when HCl is getting collected in the jar, you can see fumes, the gas fumes on the top of it, like flowing like that, white fumes. So that would be colorless fumes in moisture. So that is your HCl. Moving on to question number 8. Ferric hydroxide is a reddish brown PPT. Ferric hydroxide, reddish brown PPT. If you have issues with learning this chapter, students, please make sure that you drop me a message in the comment section, and I will make a very specific video on methods and ways how you can learn the colors of the PPTs, the equations, and how you can retain that in your brain. And whenever you see a question, you can quickly come up with the answer. Okay. Now, moving on to, we have a reddish brown precipitate which is insoluble in excess sodium hydroxide. So, insoluble in excess sodium hydroxide. Next, I have copper hydroxide is a dash PPT. So, copper hydroxide is a pale blue PPT. That is in excess of ammonium hydroxide. That is soluble in excess ammonium hydroxide. Then third is zinc hydroxide. Zinc hydroxide is a white PPT. So zinc hydroxide is a white PPT, and that is also soluble in excess sodium hydroxide. Now calcium salts with ammonium hydroxide give no reaction. Magnesium hydroxide is a white PPT dash in excess ammonium hydroxide, that is insoluble in excess ammonium hydroxide. So students, I do have a very you can say shortcut tricks to learn all of these colors, or whether it's soluble, insoluble, the way I have kept them in mind, and the way I retrieve them from my brain very quickly when I read a question. So if you would like to learn that shortcut trick, and you know, would you like me to help you out in that? Please make sure you let me know that, ma'am, please go ahead and teach us the shortcut method to make sure that analytical chemistry is not so difficult for you, and you can quickly learn it and retrieve it from your brains. Okay, students, let's move on to question number 9. So question number 9 is write balanced chemical equation for the following reactions. So let's come back on this question at the end and move on, because all of these equations would need more space, and I'll take some space down there. Now let's look at question number 10. Match the following. When okay, yellow salt solution. So yellow is ferric salt. So ferric salt. Then pale green salt solution is ferrous salt. Ferrous salt. Sometimes when you have such colors given, you don't even need the options, you would directly know the answer. Then you have blue salt solution. Blue is generally, you always pick up copper from that. So if you look at the options, your answer would be cupric salt. Cupric salt. Green colored salt will be copper carbonate. Copper carbonate. Then colorless solution would be zinc salt. Moving on to question number 11. So lead hydroxide is soluble in sodium hydroxide. That is true. Lead hydroxide is soluble in ammonium hydroxide. That is false. Zinc hydroxide is insoluble in sodium hydroxide is also false. Sulfate is detected by using dilute sulfuric acid is false. Copper oxide reacts both with acid and alkali. That is false. Copper oxide is not an amphoteric oxide. So false. Now, this is your question number 4. I found space down here. I added a page here. So you have question 4 answers on the screen. If you would like, you can pause the video and take a screenshot, or you can take a note of it. Okay, so this is what we discussed. I just wrote it as whatever we discussed. So there is nothing different. If while discussing it you took notes or some certain points, then that is the same thing here. Okay, moving on to question number 9. Write balanced chemical equation for the following reactions. So I'll just number here, put a number down here. So I'm on question 9, first part. So this says ammonium hydroxide is added to copper sulfate solution, first a little and then in excess. So you have ammonium hydroxide and copper sulfate. So let me write that copper sulfate CuSO4 and ammonium hydroxide NH4OH. So first in little, so you will get CuOH whole twice plus NH4 whole twice SO4, and then in excess, so you will be putting this again here. So CuOH whole twice plus NH4OH, and now this is the big compound that a lot of students are very scared of. So you have Cu NH3. Let me just put it like this: whole NH3 whole 4 and OH whole twice plus water. And then the second question says ammonium hydroxide is added to zinc nitrate solution, then the same thing, little and then in excess. So zinc nitrate and ammonium hydroxide. So zinc nitrate would be ZnNO3 whole twice plus ammonium hydroxide NH4OH would give you ZnOH whole twice plus NH4NO3. Then when you're adding in excess, so you'll have ZnOH whole twice plus NH4OH giving you ZnNH3 whole 4 OH whole twice plus H2O. So once you learn one of them, all of them actually come out in the similar fashion. Let's move on to the third one. Sodium hydroxide is added to lead nitrate, first little and then in excess. So you have sodium hydroxide and lead nitrate. Lead nitrate and sodium hydroxide. So lead nitrate is PbNO3 whole twice plus sodium hydroxide is NaOH. That would give me PbOH whole twice plus NaNO3, and then in excess, so PbOH whole twice, PbOH whole twice plus NaOH will give me Na2 PbO2 plus water. Okay, let me just check that once again. Na2 PbO2 plus, yes, that's correct. Now I have not balanced any of these equations, so make sure that you balance them on your own. If you're not able to do it, please let me know. I will be happy to help you out. Not just this, students, anything in chemistry that you may need some help with, please reach out to me. I am always happy to help out. Now moving on to question number part 4. So ammonium hydroxide is added to ferric chloride solution. So I have ammonium hydroxide and ferric chloride. Okay, ferric chloride is FeCl3. So ferric chloride FeCl3 plus ammonium hydroxide NH4OH would give me FeOH whole thrice plus NH4Cl. Then moving on to the last part, barium chloride solution is added to sodium sulfate solution. So barium chloride BaCl2 plus barium chloride is added to sodium sulfate. So sodium is Na2SO4. So let's make the equation. Fifth, barium BaCl2 plus sodium, what was that? Sodium sulfate Na2SO4 will give me BaSO4 plus NaCl. Okay students, I'll just zoom out and I'll You can take a screenshot of the equations if you need. You can pause it right here. So, my dear students, this is where we conclude test 4. I understand that there's not a lot that we could discuss in each question like we always do for other test papers. But because this is analytical chemistry, like it's direct, like you have to learn the equations and understand the colors of PPT directly. There's nothing else we can go in logical reasoning. But I do know a shortcut method to learn the whole chapter by a method of forming a chart. So if that is something you are interested in, please do reach out to me and let me know that you would like some help on the chapter, and I'll be happy to make a video on that. So if you have any doubts in the test paper so far, please make sure that you can check them from the video. If still you are not able to follow it, I'll be happy to help again. But if there is any part of it, for example, you don't understand the access solution ones or any particular portion in specific, and you want to practice more questions on that, let me know. I can happily upload more test papers on that portion individually. Other than that, even after this series, we will have a series of sample papers and revisions of the chapters happening, and eventually we'll have more test papers and more worksheets coming up. So stay tuned for more content, and you would definitely score a really good if you focus on these questions. These are highly important board questions, so make sure that you are paying attention and practicing them well. So that's it for today. Make sure that you subscribe to the channel and stay tuned for more content that will come up. Thank you so much. I hope you have a wonderful day.